Oh, we got 2 more submissions since the last time I checked it, like a few minutes ago.
Somebody's in the lab over there.
Talk about last minute. All right, well, let's go ahead and get started. I think I might have fixed the problem, so let's go ahead and give it a try. Okay, so we'll cancel the... Yep, go ahead.
Are we ever going to do, like,
9 months later,
any homework in this class where we write our own code to do a specific task?
In this class, we do not do that. But I will try to explain, how I write my algorithms. So if you want to, you can kind of borrow the same concept, when you move on to cisp300. But in this class, we pretty much, just focus on the traces. So I give you the code, and you guys have to know, how to trace the code, because I want to make sure that everybody in this class knows exactly what is going on when you execute a particular statement in C or, in any language. And that's basically the first priority of this class, is to know what, a programming language, or how a particular statement will get it done, will get its function done.
Okay. I thought that in particular when we looked at designing some code, like when we're talking about top down and the other. I thought that was especially.
We talked about the general approach, but in this class, I typically don't, really talk about, how to do it exactly, or you won't have an assignment to do it. If you want to get some practice, I can do that. I can give you, some practice, examples, but I won't, have the entire class, to have to do that homework. It's mostly because, it's hard enough to get the basic ideas down, first, and until I know people, already know the concepts, really well, I cannot really give homework assignments and ask people to write their own algorithm.
Yeah. It's like we're still learning the language, and we can't, write a book.
Kind of like that, I understand why, you might want to, have some homework assignments where you actually get to write or design your own algorithm, but it's not. It's harder to do that, because unless you have a good set of vocabulary, it's hard to write, something in a particular language, and it's the same thing with programming in this case.
How does the code actually interact with the code?
How does the code interact with the computer?
Like, how does this all tie into the computer?
Okay. Well, I can give you one example. I can give you an example of how this. So you want to know how a program that we write actually gets executed on a computer instead of being traced by hand like what we do in the class. Is that the question?
Yeah.
Okay, I can give you one quick demonstration. That's a very good question. I think it's a valid question for this class. It's not something that we'll do in this class. Again, I just want to emphasize that, because in this class we are just focused mostly on pseudocode. So what I will do now is I'm going to give you an example. I will write this program, exactly this program, in the C programming language, and then I can show you how you can actually run the program, and the whole process of getting this program to quote unquote compile and execute on the computer itself. Okay, so obviously this part is out of the scope of this class. You will not be expected to do this on your own with your own homework assignment. But since you asked that question, I think it's a fair question to ask, and this is a quick illustration of how to get it done in this class. Okay, so the first thing you have to do is to create a file that is similar to the pseudocode in the spreadsheet, but you have to create a plain text file that is written in C in this case. So what I'll do is I'll just I'll call this M1, which is the name of the subroutine. When you write an actual program, the syntax becomes a lot more important, and there's a whole bunch of little detail you have to take care of when you write a program in an actual programming language. For instance, in this case, which ones are my global variables? Can someone name the global variables in this case? They're all global variables because we don't have any local in this particular case. So what we'll do in C is we have to declare that X is a global variable and so is R. Okay, this is how you say that they are global variables. And then you have to define the subroutine. But the way you define the subroutine like this is you have to start with a void, because we have not talked about what a return value is. So there's a lot more stuff to take care of when you write when you write a program in an actual programming language. We can keep the name M1. There are no parameters, so we have to put another void here. And then you have to use the curly braces, to basically, to start the definition of a subroutine and to end the definition of a subroutine. And then inside you have about the same thing if x is greater than 0, but we don't say then in this case. We just use the curly braces to enclose what we want to do if the condition is true, and then we use else to indicate what we want to do when the condition is false. We don't use the left arrow to mean assignment. We actually use the single equal symbol to mean assignment in C. And then over here we have about the same thing. X gets x minus 1. And then we want to invoke M1 again. But when you invoke M1 again in C, you don't say invoke, you just say M1. But then you have to include the parentheses, even though there's nothing inside. And then you'll say R gets R times 2, just like that. Okay. When you write programs in C, everything starts with what we call a main function. In other words, you have a very special subroutine called main, and everything starts with main. So that's why it's not really quite the same as what we talk about in a class, because in this case you have a subroutine called main, and you have to make it like this. This is a template of the main function in C, and then you say x equals 3, and then you invoke M1, which is just M1 open paren and close paren. Okay. Now this program doesn't really print anything. Okay, even though it will go through all the calculations. So instead of printing nothing in the end, I'm going to use a printf statement to print out the actual value of x and r at the end. So I can say, x equals %d, r equals %d. To basically say I want to print out, two integers. The first one is x and the second one is r. Okay, so this will give us, some results at the end, and then we have to say return 0 to make the compiler happy. In other words, if you compare the C version of this program against the pseudocode version of this program, the C version is actually longer. Okay, because the syntax of C is a little bit more cumbersome in some cases, and in some other cases it's actually cleaner compared to pseudocode. But you also have to make sure that your syntax is right 100%, because otherwise the compiler will come back and say, I don't understand what you're saying, and your program cannot execute. Whereas in pseudocode, because I am the one who's reading it, as long as, and you are the one who's reading it, as long as it is clear to you and I, what a particular line is doing, it's okay. But in this case, if you miss a semicolon, which is insignificant to a human being, if I miss this semicolon here, which is insignificant to us, the compiler will stop compiling and just say, I don't understand what you're saying here. Okay, so that's why we don't use an actual programming language in this class, is so that we can focus on the logic of the statements and not the syntax of the statement. Now, after you write a program like that in C, you have to compile it. Because what this is, okay, m1.c, if I use cat, which is type in DOS, it is nothing more than a plain text file. In other words, you can write it using Notepad. Okay. The computer does not natively understand what this program wants to do, and you have to compile or translate these instructions or these statements into a form that your processor can understand, and that is the job of a compiler. In this case, the compiler is GCC, which stands for the GNU C compiler. And then you can specify the output file name, which is an executable, and an input file name, which is the file name that the name of the file that we just created. And the compilation is good. I just run the program, and it shows that when this is all done, x will have a value of 0, and r will have a value of 8.
But as to it's a whole bunch of numbers and variables. Mm-hmm. And that's what the processor computes once it's compiled?
Once it compiles, the processor will run the program basically the same way as we trace the program in this class, except it runs it much faster and just with a lot more precision. But other than that, it should do exactly what we do in this class. Okay, so this is good because now we know what at the end of the execution of this program, r should end up with a value of 8. So when I trace it by hand, I should come to the same conclusion, because the C version is just translating, it's just changing the syntax or the grammar of how to express the logic. It does not change the meaning of the logic. So that means, if I do it by hand, I should come to the same conclusion when I get to the end of the execution of this algorithm. Is that okay? I mean, did I answer your question?
Yeah, that was helpful.
Okay. So let me go ahead and trace the program by hand this time. Now you can also see that when you run a program in C, does it give you a trace? Does it show you line by line what the program is doing? Nope, not at all. If I don't have a printf statement, at the end of the main function, it won't even print the result. Okay, so that's the difference between using an actual programming language, for a programming class, where you don't really get to see how it is done, versus the way we do it with a trace. Because when we trace the program, we know we are supposed to know how each line is going to get its job done.
So once you learn algorithm design, you can pretty much go learn any syntax.
Exactly. The point is the syntax should be the least of your worries. Okay, the meaning of each kind of statement is more important than the actual syntax. If I make a mistake here, okay, just to make this conversation more relevant, if I make a mistake here and just say I forget one semicolon, okay, the compiler will complain. Okay, the compiler complains, and it says in this case it's a fairly good error message, because it says it's expecting a semicolon and it's not there. Okay. But this is not a big problem, because the compiler can spot these problems. If I have a logic error, the compiler cannot spot the logic error. So that's why I said the syntax of a programming language should be your last worry, the least of your worry, because it can be caught by a compiler. It can be done mechanically. But the meaning of your program is not something that a compiler actually understands and can verify for you. Okay. And then what we talk about in this class is not only relevant to C. If you want to write a program in PHP, like for a web script, or if you want to write a program in Perl or Python as a system script, it's the same thing. What we learn in this class is universally true for most modern programming languages. In fact, I cannot name one that does not conform to what we talk about in this class. Okay, so that's why this class is somewhat universal. You can learn other programming languages after this class without having to worry about the meaning of the statements anymore, and just focus on the syntax. And there are special features with each programming language that is kind of extending beyond what we talk about in this class. So you can focus on those features in your other classes. Okay. So we'll go ahead and let me just first make sure that the recording is recording from the right channel. Okay, looks like it is. That's good. Okay. So are there any questions about what I just illustrated, the process of writing a program in the C programming language, compiling it, and then running it? Yep.
It's more of I've dabbled a little bit with like VB, and what is the standard for writing in, say, C? And are they smart kind of like that, where indentations are kind of automatic, or are they just
the indentations of most programming languages is optional. The compiler does not care. Okay, let me show you what I mean by the compiler does not care. I have to add this semicolon back because that has nothing to do with line numbers. Okay, so let me show you what I mean by the compiler does not care. Okay, so now I have the entire program, other than the first line, combined onto one single line. The pound thing cannot be on the same line, because of it belongs to the preprocessor and not really the compiler. So that one has to be on a separate line. I can get rid of that one empty line. So the program that I just wrote, I just combined everything into one single line. Now to a person, it becomes kind of difficult to read. You can still read it because with some editors like the one that I'm using right now, if you put the cursor on a curly brace or a parenthesis, it actually tells you where is the other side or the matching beginning or the end of that pair. So that makes it a little bit easier to read, but nonetheless it is a lot harder than it was. Okay, now let's see what the compiler thinks of it. The compiler thinks, hey, no problem. It's just as easy to read as the previous version. Okay, so this is true for almost every programming languages out there except for Python. Okay, Python is the only programming language where indentation is meaningful to the programming language itself. Whereas for all programming languages, all other programming languages, indentation is only for the human eye, so that we can match the beginning and the end of a block.
I think that was actually more of my question, is because I noticed when you write something in VB, the if statements and such, they line up on their own. It kind of snaps into place. And I was curious if there are other programs that are similar.
You are basically looking for what we call a smart editor.
Correct.
Yeah, a smart editor that has syntax highlighting and then automatic indentation and stuff like that, and there are tons of those.
Okay.
If you want one that works really well in Windows, it's called Notepad++. Okay, it's not Notepad, it's called Notepad++. It's an open source program. You can download and use it for free. And it will work for just about any programming language, including non-programming languages like HTML. Yeah, so it will do the syntax highlighting, it will highlight all the tags and stuff like that. So, good questions. Any other questions related to what we are just talking about here? No questions? Okay. How many people have already programmed a little bit in C or VB or some other programming languages? Okay. Okay, so I'm going to minimize this window, and then we go back and try to trace this code by hand. But now we know the program should end up with x being 0 and r being 8. But how does it get it done? That's the question that we focus in this class. Is how do we get that done? So let me see if that works this time. Yep, it works. See, the resizing of the screen was not working before because by default the Windows Manager was using the wrong driver. It's using the VESA driver, VESA driver, which does not take into account of the graphics card that we are actually using. Yep.
Is this a new algorithm, or is this one we're using in the previous?
This is our homework.
Oh, the homework. Oh, sorry.
Yep. This is our homework. And we'll just go ahead and see what the answer of the homework is. Even if I don't grade the homework as quickly as I possibly can, it is still important to let you guys know what is the proper answer of the homework assignments. So we'll go ahead and get this one done first. Okay. So the precondition is we don't know anything. We don't need to know anything about x or y, x or r. If you put some specific values here, it's not wrong. It's just that they will be overwritten before they get used. So you can put anything there. We start with line 10. Line 10 is initializing x to 3, and then we go to line 11. Line 11 is invoking M1. When you invoke a subroutine, there are two things to do, and by this time, this should be, I should sound like a broken record at this time. Okay, if I do not sound like a broken record, then I will start to worry. Okay, there are two things to do when you invoke a subroutine. The first thing is to start a new column, allocate a column, and call that the return line number. And then remember where the subroutine is supposed to go back to when it's done. Since the invocation is on line 11, there are no more lines after line 11. That means the return line number should be post to basically indicate that we'll be all done with this algorithm when the subroutine is done. And then you have to continue execution on the first line of the subroutine. The first line of the subroutine in this case is line 2, so we continue execution on line 2. Line 2 is asking the question, x is greater than 0, is it true or is it false?
True.
Okay, it is true at this time. And then we go to line 3, x gets decremented from 3 to 2. We go to line 4, we invoke M1 again. So we use another column, we allocate yet another column, label it return line number, and this time we have to return to line 5 for this particular invocation. Question?
No.
Oh, okay. And then we continue execution again, in the subroutine that we're invoking, and we start from the very beginning. We have to start with line 2 again. Okay, so we ask the question again, x is greater than 0 is still true because x has a value of 3 at this time. So we continue execution onto line 3. We decrement x, x becomes 1, then we go to line 4, and then we invoke again. We allocate another column, and the return line number is line 5 again. Now, if one trace, if one submission of this trace uses the same column over and over again instead of allocating new columns, it will see major deductions in points, because it is very important to keep remembering that we have to allocate a new column every single time that you have to allocate a column for the return line number. Okay, so we go back to line 2. It's still asking the question, and it is still true this time. This is the last time it will be true. X is decremented from 1 to 0. We go to line 4 again, and then we have to set up another return line number column. And then we continue execution in the subroutine starting with line 2. X is greater than 0 is finally false. Okay. Now, instead of going to line 3, we have to go to line 7, because line 7 is the only line of the else of this conditional statement. And all it is going to do is to change R to 1. So whatever R was will now be updated to 1. Then we move on to line 9, excuse me. Line 9 is the end of the subroutine. There are two things we have to do. So once again, I should sound like a broken record at this time, because the two things we have to do is, first, we want to locate the rightmost return line number column, which is column H in this case. It tells me that I have to go back to line 5, so I write down the line 5 here just to remind myself where I'm supposed to go to next. And then the second thing you want to do on line 9 is to deallocate this particular column, to basically say I don't need it anymore. Whatever purpose it has, it is now done. Are we doing okay so far? Okay. So now we continue execution on line 5. Line 5 is here. It multiplies R by 2 and then put it back into R. R has a value of 1 at this time. 1 times 2 is 2, and then we put 2 back into R, so column D is now updated to 2. Then we get out of the conditional statement, go on to line 9. Line 9 once again has those two things to do. I look up column G. It tells me I have to continue execution on line 5. So let me split the screen a little bit here so we can scroll the bottom portion differently. There we go. So we are back to, on line 9, we have to remember to deallocate column G. So column G is now deallocated. We continue execution on line 5. Line 5 says we have to multiply R by 2 and then put it back into R. R now has a value of 2. 2 times 2 is 4, and we put 4 back into R. Then we continue on line 9. We look up the rightmost return line number column. This time it is column F. It tells me we have to go back to line 5, and then we deallocate that column. That column is no longer useful to me. Then we continue execution on line 5. Line 5 says we have to multiply R by 2. R has a value of 4. Now it becomes 8. Then we continue execution on line 9 again. Line 9 is the end of the subroutine. We look up the rightmost column that has a return line number column, and it is column E this time. Column E tells me I have to go back to post. Then I have to go back and deallocate that particular column. And when we continue execution at post, we know we are at the end of the entire algorithm, and we are done. Are there any questions about this trace? When you do it on your own computer, I don't think you will have to do the tricks that I did, splitting the screen and doing all sorts of stuff like that. Because first of all, most of you will not be magnifying it to 145%, and two, most of you will not be working with the XGA resolution on your own screen. Most, even laptop computers have a higher resolution than this. If you have a netbook, and then it may be a little bit pushed, squished. Are there any questions about this trace? No questions? Okay. So what I'll do is I will save this file first. It will be in today's folder. And then we can talk about the new homework assignment. Okay, so let's go back to the class itself. And, before I forget, I keep forgetting this part here. Here's the row sheet for today. Should not take you too long. Just write your name next to your printed name, and that's it. That's all I need. Okay, so the next homework assignment, or the homework assignment that you have to do by next Thursday, is about parameters. The format of the homework assignment is pretty much the same thing. You open up the file, and then you just trace it in OpenOffice Calc or LibreOffice Calc. LibreOffice Calc. This is the algorithm, okay, that you have to trace. It looks really messy, it looks really long, but it's not, okay, because a lot of this stuff here do not execute, okay. They're not statements that you can actually execute. I can identify the ones that you can actually execute. 1, 2, okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So there are only 8 lines that are, actually meaningful, not counting the end of a subroutine. If you add the end of the subroutine, then you have 8 plus 3, which is 11 lines that actually do something that you have to trace, which is not too bad. I don't think that is too bad at all. Okay, what this assignment is forcing you to do is to review the concepts of by-val parameters, local variables, and also by-ref parameters. Those are the 3 concepts that this will test you. It doesn't test you with all the combination of the concepts, only with certain concepts. So we can take a look at the algorithm itself. Sub-T is nothing more than the swap subroutine. It's just a swap subroutine that we have already talked about. Sub-S is a little bit different. It doesn't really do anything particularly useful. You just have to follow the line 13, 14, and 15 to see what it will do. And sub-R is the overall subroutine. In this case, there are no global variables. Everything are either local or it is a parameter. And your job is just to keep track of what this program is supposed to do, and give me the proper trace, and that's the end of it. Are there any questions about this homework assignment? It is due in a week. No questions? Okay. And that means we can continue to talk about the parameters. Now, last time we have already talked about all the types of parameters. There are only 2 types of parameters. One is by value or by val. The other one is by reference or by ref. Those are the only 2 parameters that we can use in most modern programming languages. Plus local variables, which is not a form of parameters, but yet it is still kind of similar because you have to allocate space for local variables just the same way as you have to allocate for the parameters. What we'll do today is to talk about the combinations, all the possible combinations of passing a parameter to another parameter. And I believe that is already discussed in the updated material on subroutines. So let me take a look at that one first, just to make sure that we have that already covered. See right here, the most tricky one is taking a by ref parameter and pass it again by reference again. Okay, so I will talk about what that means. I'm not going to use the same example here, but I will use another example. This one is a full trace, just like what we talked about in the class, except it also has an explanation column, so you can actually see how each line is explained. So I definitely want everybody in the class to read this particular module because it has a much better way to explain how things happen compared to the old notes. Are there any questions about parameters at this point before we talk about the 4 possible combinations? Yep.
What's the difference between, sometimes I've seen the word argument, versus, like a parameter?
They are not exactly the same thing. Okay, a parameter is from the perspective of the subroutine. Okay, it's the in tray. Okay, so the in tray itself is called a parameter. Argument is usually referred to as the stuff that you put onto the in tray.
So, the thing that you put in the invoke statement would be the argument, and then the parameter would be inside the subroutine?
Correct. That is the correct interpretation. So if you want to kind of pinpoint the exact meaning of those 2 words, they are different because one refers to the tray itself, and the other one refers to the stuff that you put onto the tray. Okay, but in a lot of classes, the 2 terms are used, pretty much interchangeably. That's a good question. So let's go ahead and look at the 4 possible cases today, and we'll have time to spare, and then we'll start to talk about return values. Okay, return values is a very useful concept. It is not 100% needed, but it is a very useful concept. Okay. So let's go ahead and work with some really simple ones that we have seen already, but just for completeness sake, we'll go ahead and do it anyway. Okay, so we'll say define sub t, pass by value x, and what we'll do to x is x gets x plus 1, and define sub. So none of these sample programs are actually useful, in any way, but I just want to make sure that we understand the effect of, passing a by-val parameter, by-val again, to another subroutine. So invoke t, I use my x to pass to the x of the subroutine that I'm invoking, and then we have n define sub, and then outside of both definitions or both subroutine definitions, we have invoke s, and then we use, doesn't matter what we use in this case to pass to x. We'll just pick a particular value to do it. Okay, so here we have, a program that really doesn't do anything useful, and you will see why I say that. Okay, some people can look at this, pseudocode and immediately understand, hey, why do we even bother to do this? But we'll go ahead and trace it anyway, just to see why it is pointless. Even though it is pointless, it still illustrates, what happens when you pass a by-val parameter, by-val again, to another subroutine. That's the whole point of this code here, is to illustrate what happens in that case. We have line number, and we have a precondition. There's nothing to say about the precondition because we don't have any global variables. Now, how do I know there are no global variables? Because all the names are accounted for by parameters. X inside t is a by-val parameter. X inside s is also a by-val parameter. So that means, I don't have any need of any global variables in this case. I start execution on line 9. The first thing we'll do is to allocate a column called return line number. But since subroutine s also has a parameter called x, we also have to allocate for parameter x at the same time. Thank you. The return line number in this case is post because there are no lines after line 9. And then x being a parameter instead of a local variable starts with a value that is specified by the invoke statement. The invoke statement says let x start with a value of 3, so that's what we'll do. Are we doing okay so far with this?
What is invoke s? What does the s stand for?
That's the name of the subroutine that we're invoking. I'm just picking single letters, so we don't have to type too much. Okay. So now we get into the subroutine. Subroutine s. S doesn't really do anything. It's all it does is to invoke another subroutine. So on line 7, we are invoking subroutine t. So every time we invoke a subroutine, we have to allocate one column for the return line number and one column for each parameter that we are passing. In this case, we have parameter x again. And the return line number is the line that is logically following the invoke statement. Since the invoke statement is on line 7, the line that is logically following in this case is line 8. X is passed by value. So the question is, what do I put here?
3.
Okay, we pick 3 because the x on the left-hand side of the right arrow refers to the x that we know already, which is column C. The x on the right-hand side of the right arrow refers to the x that we are trying to set up at this point, so that is column E. So that's what we're doing, is to make both of them the same. And then we continue execution inside the subroutine that we are invoking, and that's line 3. Line 3 doesn't do a whole lot of stuff. It is adding 1 to x. But we're only adding 1 to the x of column E and not the one in column C because it can only see the x that it creates for itself, for that particular invocation. Anything that is already created by previous invocations cannot be seen by the subroutine. Is that part okay? Is that part clear? Why we are only updating column E instead of column C? Okay. So column E is now updated to become 4. Then we go to line 4, and this is why I said this whole thing is useless, because at the end of a subroutine we have to deallocate not just the return line number, but also all the parameters and also local variables that we allocated earlier for this invocation. But before we do that, we have to remember, oh, this is line 8. We have to continue execution on line 8, and that's what we'll remember first. and then we'll say, okay, these two columns are no longer useful, so we get rid of these, and then we continue execution on line 8. Line 8 is the end of the other subroutine. It doesn't really do anything useful. We have to remember where to go back to, which is post, and then we say these two columns are no longer in use, and they are now deallocated. Then we continue execution at post, which means we're at the end of the trace in this case. Are we doing okay so far? This is the easiest one in terms of conceptually. This is the easiest one. We'll save it in today's folder. We'll call it by-val by-val because we are passing a by-val parameter by-val again to another subroutine. The next one is going to be, well, we can do a by-ref by-val, but we'll change this one to by-ref first. So we're changing a by-val. We're passing a by-val parameter to a by-ref parameter. This is what we are changing. But because of this change, I also have to change the arrow because every time I use a by-ref parameter in this class, we use a double-sided arrow to remind ourselves whatever happens to the parameter will also happen to the thing that you use to specify the parameter. Are we doing okay so far with this example? And I have to save the file as another file name, so we have to save it as by-val by-rev. The trace is not going to be exactly the same, so we'll go ahead and change it a little bit here. Okay. We still start execution on line 9 because that's the first line that is outside of the definition of all the subroutines. And we're still passing 3 by value to x here. And that's why x still has a value of 3 to begin with. The return line number is still post. So this part has not changed. We go into the subroutine, we start execution on line 7. Line 7 is still doing pretty much the same thing as last time. We have to remember where to go back to when t is finished, and that will be line 8. That part is the same. We still have a parameter x, but this time parameter x is going to take a little bit more space as a column because parameter x of t is not passed by value, it is passed by reference. So the question now is, what do I write here in cell E6? What do I write here to represent that this is a parameter that is passed by reference, and is a reference to what?
Also known as column C.
It is also known as column C. Okay. Now, how do we know that? We have to look at the actual invocation itself. The invocation uses parameter x of subroutine S, which is this parameter here, to specify parameter x of the subroutine that we're invoking, which is the parameter x of subroutine T, which is passed by reference. So that means parameter x of T becomes an alias of parameter x of subroutine S. Parameter x of subroutine S is column C, and that's why subroutine x of T becomes a reference or an alias of that particular column. So once again, it is kind of important to realize that at this point, we do not refer to this as aka x. Because if I set aka x, also known as variable x, then it is a source of confusion because which parameter x are we talking about? But when we say column C, it is crystal clear which column we are talking about because there's only one column C even though there are 2 parameter x's. Are we doing okay so far with this concept? Because this one is a little bit more tricky. How do you pass a by-val parameter again, but pass it by reference the next time? Now, what is more interesting is the effect of the following statement. Okay, what happens when we execute line 3? When we execute line 3 says, we want to, let's look at the right-hand side first. The right-hand side says we want to look at the value of x at this point. We add 1 to it. So we look at x. But T does not look at column C right away. T only has access to its own parameters. Well, if it is its own parameter, this is the x that is looking up. It sees that x as its own parameter is an alias of column C. So then it looks into column C and find out that column C has a value of 3. And that's why we know the right-hand side of the assignment statement is 3 plus 1, which is 4. Okay. What do we do with the right-hand side? We change the left-hand side with that value. The left-hand side is x again, but this time it can only access the x of its own, which is column E. But column E is nothing more than an alias. So that's why we don't update this cell here to 4. We have to update column C to 4 instead. Are we doing okay so far with this? Okay. Now this is the tricky part, because you don't update a parameter that is passed by reference. You change what it refers to. That is the key. Okay. After line 3, we have the line 4, which is the end of the subroutine T. And this part is pretty much the same. We deallocate both of those columns, and then we go to the line of the return line number, which is line 8. When we get to line 8, we do the same thing. We look up the return line number. We understand we have to go to post, and then we deallocate these 2 columns. And then since we're at post, we know we are at the end of this pseudocode. We are all done. Are there any questions about this trace? It is the second case. Okay, it's the second case where you have a by-val parameter x, which is passed by reference again to another subroutine. Are we doing okay so far? Okay. So let me save this again, and this time we'll change this program to something a little bit different. Okay, so this time we have to change it so that subroutine S has a parameter that is passed by reference already, and then we'll pass it either by reference or by value to T. So let me insert a row here, because I need my own global variable in this case. So we'll just use R as my global variable, and we'll just say that R starts with the value of 3. Okay, just be consistent. And then we also have to change this to by rev, because that's what we are trying to illustrate here. And we'll change this guy to by val. And then we have to change this statement here and use R to specify X. That. And then we'll save the file again, but this time as by rev first, and then by val as the second invocation. And then we'll take a look at what we'll do in this case. I think this time, it's a little bit more changes, so I have to, really get rid of the merge columns. I don't really have to get rid of it. I have to insert new rows, at some point. So I'll go ahead and insert a row first. Yep, go ahead.
We don't need the double arrow for the invoke T,
Correct.
right?
Yep, you're correct. This one is not a double arrow anymore because it is passed by value, so it only has to be a right arrow. Thank you. Good observation. Okay, very good. So this time I do have something to say about the precondition, because I do have one global variable in this case. So that means I have to insert one more column if I want to keep the merged columns later on. I do have one global variable, which in this case is R. And R can start with any value because I'm going to change it next. So, and I already saved the file name correctly, so I'm good. We start execution on line 9, because line 9 is the first line that is outside of the definition of any subroutine. R gets updated to 3. That's the easy one. On line 10, we are invoking the subroutine. We are invoking subroutine S, so we have to deal with the return line number. And also this time we have to deal with parameter X. The question is, what is parameter X in this case?
3.
Okay, well, it's not 3. It is passed by reference. Every time you see the double-sided arrow, this parameter is passed by reference, which means we are using global variable R to specify parameter X. When you pass by reference, the parameter becomes an alias of whatever you use to specify the parameter. Okay. In this case, global variable R is living in column B, and we want parameter X passed by reference to become an alias of column B. So the way to say that is, parameter X of S becomes an alias of column B. Do we have any questions about this part? Nope. Okay. So now we can move on and go into the subroutine and continue execution on line 7. Line 7 is going to pass x to x, but this time it is by value. Let's go ahead and deal with the easy one first. Okay, the return line number is going to be the line following line 7, which is line 8. That's the easy part. What about parameter x of subroutine T?
Just gets the AK column B.
But it can be any expression. Okay.
Okay.
But this one, see, it can be x times 1. Okay. In other words, whatever you can have any type of expression to the left-hand side of the right arrow when you pass by value. It is a copy, but it is not a copy of the reference. It's a copy of whatever the reference refer to. Or you have to evaluate. The other way to look at this, or the proper way to look at this, is whatever this expression evaluates to, that's what you use to specify the parameter that is passed by value. Is that okay so far? If it is x times 2 and then the whole thing plus 1 and whatever, that becomes the value that you have to use to initialize this parameter x that is passed by value. So in this case, if we just so happens to have a very simple expression, which is just x, but this x on the left-hand side of the right arrow refers to the x that we already know, which is the x that is passed by reference from the outside of the subroutine. So if when you look at the trace, this is the x that we are talking about. It does not have a value on its own. It is a reference to column B. Column B has a value of 3, and that's why column F, which is parameter x of t, will also have a value of 3. Are we doing okay this time? Okay, so you just have to remember this x here can be any expression. It can be a constant, can be a global variable, can be a local variable, can be a bi-val parameter, can be any expression. You have to evaluate the expression first, make it come to a particular single value. In this case, it has to be an integer value before you use that to specify column F in this particular case. Yep.
Would it be a problem if there is a global variable f as well as x as well as a bi-value x?
Then the bi-value x will hide the presence of the global variable x. In other words, if you have a global variable of any name, and at the same time inside the subroutine you have something of the same name, be it a local variable, a bi-val parameter, or a bi-ref parameter, the local definition will hide the global definition. Okay. Good questions? So now we continue execution in subroutine T, with line 3. Line 3 says we want to add 1 to x, but since subroutine T, or this invocation of subroutine T, can only see column E and column F, this is the x that we're dealing with. Okay, so we update it to become 4, and then we continue execution on line 4. Line 4 is the end of the subroutine. We say we have to continue execution at line 8, and then we can deallocate these 2 columns. Now we are continuing execution on line 8. It is the end of the other invocation of subroutine, in this case subroutine S, so we have to deallocate the 2 columns that we created for that. So these 2 are gone, and then we continue execution at post, which means we're at the end of the entire program. So are we doing okay with this trace? Kind of? Okay. So let me save it first. And then we only have 1 case left, okay, which is by ref. Okay, a parameter is passed by reference already, and then I pass it by reference again to another subroutine. So we'll see what happens in that case. So let me change the file name first before I make changes to the file. So this time I also make this parameter in subroutine T to also be passed by reference, which also means this right arrow also has to be changed to a double-sided arrow, because that's how we specify something is passed by reference. That's all the syntactical changes that I have to make, but in terms of the behavior of the program, it will be quite different from last time. Okay, so once again, we have the precondition of the global variable r can start with any value. On line 9, it still does the same thing, r gets a value of 3. On line 10, it is still pretty much the same thing as last time. We have to set up the return line number. We have to set up, parameter x. The return line number, just like last time, is post, and parameter x being passed by reference using, r as to specify it. It will also still be aka column B. Are we doing okay this time? Okay, it's the same so far. Okay, nothing has changed. Then we continue execution inside the subroutine starting with line 7. Now this is where things get to be different. The return line number is the easy one to take care of because we are invoking on line 7, which means when we come back we have to continue execution on line 8, just like last time. So that part has not changed. But when we specify parameter x, this time is a little bit tricky because what am I supposed to say here? We have two choices, okay? We have two choices here because we are using, okay, let me use the mouse pointer instead so that the screen capture would also take care of that. Because the right-hand side, the left-hand side of the double-sided arrow is specifying this x, and this x is the parameter x of subroutine S, which means it is actually column D. So one choice is we can write aka column D, okay? So this means we can create an alias of an alias. That's option 1. Option 2 is not to create an alias of an alias, and we only keep one single level of alias, which means instead of using aka column D, we can say this is just column. This is an alias of the same column, which is column B. Okay, and the correct answer to this question, which one do we use? Do we create an alias of an alias, or do we just pass the alias along? The answer is the second one is the proper behavior. Okay, we do not create an alias of an alias. We just pass the alias along. So that means the second answer is the correct answer. X parameter x of t is really the same alias. It is still an alias of column B. Are we doing okay this time? Yep.
Like when you say that, are you saying it from like an organizational standpoint, or do you mean like that's what the interpreter or the compiler would
That's what
actually do?
that's what all programming languages will treat passing by reference. Okay, if you have a parameter that is already passed by reference, and you pass it by reference to another parameter of another subroutine, you're just passing the alias along. You do not create an alias of an alias. Okay. But it is important. Okay, it is important because that's exactly what happens inside a computer when you have statements like this. Okay. Now this is important because what happens on line 3? On line 3, the right-hand side is, we want to evaluate what is x plus 1. We look up x is column F. Column F is an alias of column B, so we go straight to column B and we find the value is 3. So now the right-hand side of the assignment statement becomes 3 plus 1, which is 4. Now if I had created an alias of an alias, it would have to backtrack to this step first, and then it will backtrack to the actual column. From the efficiency perspective, it is less efficient. But more importantly, when you are actually doing this outside of the context of a trace like this, the computer actually does not understand when the backtracking can stop. Okay, it doesn't carry that information with it. So you can only have one level of aliasing when you're actually using a programming language. Are we doing okay so far in this case? Okay. So that means the right-hand side of line 3 is 4. The left-hand side is x. We look up x, which is column F. It is an alias of column B. So when we perform the assignment statement, we are updating not column F, but what it refers to, which is column B. So in this case, column B is the one that is updated. Not column F, not column D, but column B itself. Are we okay? Yep.
So even though we're changing R, we're really changing X?
Because X is an alias of R. they refer to the same column. Now, there's really, if you look at inside the computer, when the computer executes a program, it doesn't understand the names anymore. By the time the computer executes the instructions, there are no such things as names anymore. Okay, X and R, they're all lost. Okay, in the process of compiling a program, the names are lost. In other words, when you look at the individual instructions of a computer, they can only understand which column am I looking at, or an alias of a column. That's the only thing it can understand. And that's why, R as a global variable is nothing more than a name of column B. Parameter X of subroutine S, which is passed by reference, is an alias of the same column. Parameter X of T at this point is also an alias of column B. Column B basically has three names at this point. It is a global variable R, it is parameter X of subroutine S, it is also parameter X of subroutine T. All three refer to exactly the same thing. Okay? Are we doing okay so far with the concept of the name of a column? Kind of? Okay. So when we're all done with line 3, we go to line 4. Line 4 is the end of this subroutine. We have to remember to continue execution on line 8, and then we can go back and say these columns are no longer in use. We go to line 8, which is the end of subroutine S. We now know that, okay, we have to use the post here to remember that we have to continue execution at post. Then we can go ahead and remove these columns as well. And then when we get to post, we know we're at the end of the entire trace and we are done. Are there any questions about this particular example? We have just seen all the possible combinations of passing by val to a by ref, passing by val, by ref, and then by ref, by val. Are we doing okay so far with these concepts? Okay. So we can now start to talk about return values. Now, return values is also here. It is section 7. It is actually, it's both a simple concept to understand, it's also a difficult concept to illustrate at the same time. Okay, so in terms of tracing programs or subroutines that have return values, we have to go through a lot of kind of complicated stuff to illustrate how it is done. But in terms of concept, it's really not that difficult of a concept. We'll start with something that's easy, and you can always definitely read the notes, and this is one of the simple ones that we can do. But we'll go ahead and start with something that is different, okay? Just so that you have exposure to another example in addition to the one already in the notes that's already online. And let's go ahead and start with something like this. Define sub. I call this name, the name of this subroutine 5, F-I-V-E. And all it does is to have one statement called return, okay? But when you say return, you also have to specify a value that it is returning. In this case, it's returning a value of 5. And then we say and define sub. Proper indentation. And outside here, let's just say that we have a global variable x, and global variable x will get the value of invoking 5. Now this is something that we haven't seen before. In the past, when we execute subroutines, a subroutine or the invocation of a subroutine is always on a line on its own. It does not combine with something else. This makes it this makes it possible to combine the invocation of a subroutine with stuff that we already have done before, like assignment statements. We can put it inside a conditional statement. We can compare invoke 5 to a particular value. So this looks kind of mysterious. What are we doing here? So we'll trace it first, and then we'll go back and explain why return values are useful. So we'll go ahead and trace this code first, and then we'll go back and explain why it is a really cool thing to do, and it actually helps to simplify certain programs. Okay, line number, we have a global variable x in this case, so the precondition is, well, let's not worry about the initial value of x because we're going to change it anyway. And in this case, we start execution on line 4 because it's the only line outside of the definition of our subroutine here. When we invoke 5, we usually have a return line number. This time, we don't use a return line number anymore. Because when invoke 5 is done, we are not going to post immediately. Because there's something else on this line that we have to do, which is to complete the assignment statement. Okay? So let me just repeat what I said. There are 2 things that we have to do on line 4. The first thing we have to do on line 4 is to find out what is invoke 5 doing. Invoke 5, when it's all done, will come back with a value. And then we have to take that value that subroutine 5 specifies and use that to finish up the assignment statement. So there are 2 steps, there are 2 things to do on line 4, and that's why we cannot use a return line number, because let's just say that we continue to use return line number. Okay? The question is, what are you going to put here? Do you say line 4? Now, if you say line 4, that means we go back to line 4 from the beginning, and it will invoke 5 again, and then it will go back to line 4, and then we invoke 5 again. It will never end. Now, okay, so maybe line 4 is not a good idea as a return line number. What if we put post? Then we would miss the second half of that line, which means we won't finish the assignment operation. X will not be updated as a result. So that's why we cannot use return line number. So instead of return line number, this time I use I use return info to name this column. Return information is how I name this column. You can name it differently, but anything but return line number. Question? No. Okay. Okay. So there are several things we have to do in this case. We have to first indicate which line we're supposed to go back to. So we have to indicate, okay, we're supposed to go back to line 4. Then we have to remember what else on line 4 do we have to do? Well, we still have the assignment part that is not done yet. And the invocation itself is now replaced by a single question mark, which is basically saying it is a placeholder. Okay, I know the invocation of 5 will somehow give me a value. What am I supposed to do with that value? Oh, that value is supposed to be the right-hand side of the assignment statement. So when I get back to line 4, I will finish up the assignment operation. Okay, are we doing okay so far with kind of the general meaning of something like this? Okay. So let's go ahead and go to subroutine 5 and see what the return statement is going to do. We continue execution on line 5. Line 2, which is the only line inside the subroutine 5 that actually does anything useful, and it is something that we haven't seen before. The only thing a return statement will do is as follows. It will look up the rightmost return info column. It will copy and paste the entire cell when you do this inside a spreadsheet program, and it will change the question mark to whatever value that you're returning in the return statement. The return statement specifies that we're returning a value of 5. That's what we're going to do. Change the question mark to a 5. That's it. Okay? We do not perform the actual assignment statement at this point. All we do is to replace the question mark with the value that you're returning. We do not perform the actual statement here. Are we doing okay so far? Okay. Now we go to line 3. Line 3 says we have to continue execution on line 4, so that means the next line is line 4, and then we can, quote-unquote, erase this column. Okay. Now we are on line 4. When we get back to line 4 really does not look like this anymore. It does not look like the original code anymore because we have already resolved what invoke 5 is returning. So that means when I go back to line 4, we are continuing the execution of line 4 as described by this column, by this cell here. Can we do this? Yep.
Don't the X's cancel that information out?
That's why I said, it's kind of like that. The effect is that we are now executing the statement as if it is described by the cell C5. Okay, the column itself is gone. However, the statement of line 4 is now becoming like that. There are no other way for me to describe, the actual effect of a return statement other than this. But I understand what your concern is. The concern is, column C at this point is already gone, and how come we can still refer to it when it is deallocated? It's kind of like an after image thing. Yep.
So is this only true because it's being invoked on line 4? Like, could you way later in the program still?
You can utilize this only immediately after, the return of a subroutine. Okay. Are there any other questions about this part? Okay. So the key point here is the invocation of 5 leaves an empty spot to be filled in later. The return statement will fill in that unknown, so that by the time you get back to the statement that actually has the invoke, you now can continue the execution of that statement. Are we doing okay so far with this? Or is this not good so far? Yep.
So I mean, I understand the concept, but I'm just wondering what is the advantage of this over using a by reference? Like, since you could
Very good
return
question.
anyway.
Okay, we'll go ahead and answer the question using our good old Factorial program. Okay, the Factorial Pseudocode. We'll use that again. So this time I'll say simple return value, and then we'll go ahead and start a new spreadsheet. First of all, we'll go back and revisit our Factorial subroutine. And this time we won't use any global variables at all. We'll use a pass by reference parameter so that we can specify the value of a particular factorial of a number. Okay. So that means our factorial program will become something like this. Define sub factorial by reference the result by reference n. If n is greater than 0, then invoke factorial again. We use n-1 to specify n, and then we use r to specify r. We are basically just passing the reference of r along. And then we say r gets r times n, else r gets 1, and if n define sub. Are we doing okay so far with the Factorial subroutine? Does it look kind of similar to what we usually have? It's almost exactly the same as the previous, Factorial, except we use a parameter passed by reference to store the result. So outside of the subroutine, I still need a global variable in order to specify where the result is supposed to be stored. So that means I still need some variable here called x, so that I can say invoke factorial. Let's say we just want to find a factorial of 1, because that's not the point of this particular example. Okay, so n can start with a value of 1, but I still need to specify which variable do I want to use to store the result, right? So I still need to have some global variable, say x here, in order to specify the result, even though the only thing I want to do at the end is to print out the value of 1 factorial. Is that okay so far? If all I want to do is to print the value of 1 factorial, I still need 1 global variable in order to make it work. And I think this would be a good one for you guys to trace, because we already have introduced and understood all these concepts. So this would be a good example for you guys to trace. I will not grade it as a homework assignment, but next time someone can remind me to come back and trace this one in the class so that you can compare your trace with my trace. Okay? But I think you have all the tools that you need to trace this one already. But the key point here is I still need a global variable x in order to store the result, and then I use the global variable to print. Is that okay? And also, over here, it's kind of cumbersome. Okay, I have to first, perform the invocation, and then I can use the result that is calculated by this invocation, and then perform the calculation itself, and then update it again. Okay, so let's go ahead and save this one first. And I'll name this, factorial, but it uses by-val as well as by-ref parameters. And we'll change the code a little bit. Go ahead.
You used by-val?
There's a by-val. Oh, okay, I got it. This part is wrong. This one is supposed to be by-val. Sorry.
Okay.
Good point. Because I don't need to change n. That's why it can be passed by value only and not by reference. Okay, so now let's go ahead and take a look at another version of the factorial subroutine, and this time I can use the return value concept. So we can say define subroutine factorial. This time I have one single by-val parameter n, and I can say if n is greater than 0, then this time it is quite interesting because I can say return n times invoke factorial. N minus 1 is used to specify n. Else, return 1, and if n defines sub. Outside of the subroutine, since I'm only interested to know the value of 1 factorial, this is what I do. Print invoke factorial. 1 specifies parameter n. Let's go ahead and trace this one because I think it really helps to summarize why do we want to have a return value, because it cleans up the code considerably. Okay. We'll probably have to come back and revisit this example next time because it is a little bit complicated. Not really super duper complicated, but it is complicated in a way. Okay, so I'm saying that these two programs will do the same thing. This one still has to use a particular variable to store the result of 1 factorial. This one, on the other hand, has no global variables whatsoever. Okay, I consume and use the return value as soon as possible, and I don't need anything, as an intermediate thing to store the value of the computation. So let's also save this one into today's folder. And this is factorial using return values. And we have 5 minutes left, which is just enough time to trace this. Okay. Sheet 2, we need 1 column for comments. We need 1 for line number, but there are no global variables, so the precondition is entirely trivial. We start execution on line 9. Line 9 needs to take care of 2 things. First, we need a return info to tell us, what else do we have to do when the subroutine is done. We also need 1 for, n as a parameter. Because in order to find out what I am supposed to print, I have to first take care of the invocation of factorial. So the return info is going to be, similar to what we talked about before. It has to specify what line I'm supposed to go back to. And then we have to specify what else on that line we have to perform, and also how does the invocation of factorial relate to the execution of line 9? Well, as it turns out, factorial will tell us what value we are supposed to print. And n, since we use 1 to specify parameter n, and it's passed by value, n just has an initial value of 1. Okay, so now we are done with setting up everything in order to invoke factorial. Factorial starts with line 3, so we continue execution on line 3. Are we doing okay so far with this code? Kind of? Okay. On line 3, what do? We evaluate the condition. N is greater than 0 is true. So then we have to go to line 4. Line 4 is the really confusing one because, well, okay, it looks kind of confusing, but regardless of what else we have to do on line 4, what is the first thing we have to do on line 4? we have to invoke it first, right? We have to invoke first, then we can worry about the return statement. So that means we have to invoke factorial again, and when I used the wrong subroutine name here. This is another thing about pseudocode that is nice, because as long as we know it means the factorial subroutine is okay. Okay. So in this case we have to specify the return info again, and then we have to specify parameter n again. The return info, is supposed to tell us what else do we have to do on line 4 when factorial returns. Okay, when this invocation of factorial returns. Well, let's take a look. On line 4, we still have the return part that is not done yet, but it's a little more than that, because we still have not performed the multiplication yet, because until we know the value that invoke factorial is returning, I cannot perform the multiplication. Are we doing okay so far with how I specify the return info for line 4? Okay. And in this case is the easy one, because we have done this already. The n of n minus 1 on the left-hand side refers to the n that we already know, which is column D, which is 1. 1 minus 1 is 0. The n on the right-hand side of the right arrow is the n that we are setting up, which is column F, so this becomes 0. Okay. Are we kind of doing okay so far? I'm suspecting that we probably have to revisit this, and you should probably watch the video again if you have any doubt or about this whole thing. Okay, so now we continue execution in the subroutine that we are invoking, which is factorial again, which starts with line 3. But this time n is greater than 0 is false, because n, which is column F, has a value of 0. 0 is greater than 0 is false. So instead of going to line 4, we go to line 6. Line 6 is return 1. Now what does a return statement do again? All it does is to change, it will copy and paste the return info cell, change the question mark to the value that we are returning. What are we returning again? 1. And that's it. It does not execute that statement right away. It just changes the question mark to the value that we are returning. So even though that statement is also a return statement, it doesn't care. We are not executing that return statement. This is the end of line 6. After line 6, we go to line 8, which is the end of the subroutine. Okay, at the end of the subroutine, we have to look up the return info cell and say we are supposed to go back to line 4 to continue execution. Fine, we'll go back to line 4. And at the same time, we will deallocate the 2 columns that we have allocated earlier. Those 2 columns are gone, deallocated. When we go back to line 4 does not look like the original pseudocode anymore. Line 4 is now exactly the same as E9. Okay, cell E9 is what line 4 should look like now. In other words, we are executing return n times 1 at this point. Which n are we talking about?
D.
Column D. Column D has a value of 1. 1 times 1 is 1. Now what do we do again when we say return 1? We locate the return info cell, we copy and paste it, and then we change the question mark to the value that we're returning. What are we returning again? 1, so we change that to a 1. Do we do the print right now? No, because we just changed the question mark, right? We substitute the question mark with a value. And that's all we do when we execute a return statement. So that's the effect of line 4. Line 4 is done. We get out of the conditional statement. We get to the end of the subroutine on line 8. And line 8 is the return statement. So that means we have to look at the return info cell to remind us that we have to go to line 9 at this point. And then the rest of line 8 is to deallocate the 2 columns. Okay. O-E-M. Deallocate these 2 columns. And now we are back to line 9. But line 9 doesn't look like this anymore because the invocation is already done. We know the value that we are supposed to print at this point, and that's why we are just going to print a value of 1 to the screen, and then we are done with this entire program. Okay? So I know it is kind of convoluted because, there are multiple points where we get back to the same line to continue execution. So we'll take a look. We'll take a look at this again on next Tuesday. But please read the notes ahead of time, okay? Just so that you have some exposure. If you want to watch the video again, go ahead and watch the video again, because this stuff takes a little bit of time to sink in, and that's just a matter of reviewing all the notes and making sure that you understand the concepts.